In this video, we're going to take a look at linear velocity, which is the velocity of moving through space for your particles. Do you want your particles to move along a particular axis? This is how you're going to do it. Now, if we take a look at our ellipsoid particle emitter component, once we get down past max emission, the first one of these we have is world velocity. And you'll notice as soon as I have this guy selected and I put focus back on Unity, my particles start moving again. Now, in the last video, I added a little bit of world velocity just for the sake of demonstration. I'll go ahead and turn that back off now, and my particles will quit moving. I'm also going to take my min and max size, again, just for the sake of demonstration, and we'll pull these down to 0.1 just so we get some tighter points. I just think they're a little bit easier to read. All right, now let's talk about world velocity and local velocity. World velocity is going to move your particles along one of the global world axes. So if you want to move them up in y, if you apply a positive velocity in y, they will move up. So if I set this to 2, you'll see my particles start moving upward. Pretty basic. Let me set that back down to 0. We can take x and we can set that to 2 instead. And you'll notice, because we can see my actual move gizmo, which, just to show you, I'll click that and set that over to global, just so that you know that this is the global x-axis. So we're moving positively in x. Conversely, I could just set this to a negative value, and now we're moving in the opposite direction. So here's the funny thing, though. If you're totally new to this, it can be really confusing because here, notice I've set x to 1 in world velocity. And so you're like, okay, well, I see what that does, and you set that back to 0. And then you grab local velocity and you set that to 1 as well. And it looks like it's doing the exact same thing. Here's the critical difference, though. Let me stick with y. I don't know why. I just like seeing the particles go up. It's satisfying to me somehow. If I set my world velocity to y, and then I take my emitter and get my rotate tool out with the E key, and I start to rotate this, and really I'm just grabbing and doing some random rotation, notice that rotation isn't affecting anything. You can see it updating over here in my rotation properties under transform. We're getting some really crazy rotations, but that's not affecting the particles at all. That's because our particles are being sent along a world axis. Now, if I take my rotation and I zero it back out, and then we take our world velocity and we set y to 0. Now let's come down to local velocity and we'll set this to 1 instead, and we'll give the particles a second to get completely moving. Now if I start rotating my emitter, take a look at what happens. We start being able to affect the direction that the particles are going based on how we rotate the emitter around. Pretty cool. That's the critical difference between world and local. Local is going to be relative to the local rotation axis of your emitter. So if you have something like, I don't know, a fire hose or anything that might be changing its rotation over time, you want to be using local velocity as opposed to world velocity. If you know that that velocity is never going to need to change relative to the emitter, then you can use world. Now down from here we also have random velocity. Now to show that off, first off, let me do a couple of things here. Let's do some undoing so that we can get everybody back to where we were with no rotation. There we go. And we're going to take our world velocity and set that to 0. So now, again, we're not moving anymore. Random velocity is literally a plus or minus value that is applied locally. It's always going to be local. So keep that in mind. Now, if let's just say, case in point, I grab x as our sideways axis, and we set this to 3. Take a look at what we get.
Right, the particles are moving both in the positive x direction and the negative x direction.
And you can see overall it's a pretty even spread. We have pretty much just as many going to the right as we do going to the left. It's because, again, it's like a plus or minus value. Now this can be useful when combined with local velocity. Now there's no reason you can't use it with world as well, if you feel like it. I'm just letting you know that random is applied locally. So for instance, if I was to take my emitter and flip it around a little bit, you can see that that rotation is being taken into account. So if you're trying to keep everything nice and understandable, I would strongly advise you, if you're going to be using random, go ahead and just use local anyway. Now, for me, random is best used along with a little bit of local velocity, so let me set everything back to 0. And what I'll do is I'll add, I don't know, let's say total of 3. So this is going to start moving our particles pretty quickly. And I'll back out a little bit because we're probably going to need some room for this. Now let's take our random velocity, and I'll set this to 2. And again, it's like a plus or minus value. So what we end up with is 3 as our base, and we can go 2 faster than that or 2 slower. So we end up with a range of anywhere from 1 to 5. So that's how we end up setting up random ranges. We don't have a min and max in this case. We have a base value and then a random factor that's applied to that. It's just a different way of thinking, but it's real easy once you get your head wrapped around it. So does that make sense so far with random?
Yes, it does.
All right. Now, you can do some other cool things, like if you need a little bit of spread on your particles, for instance, we could take our y and apply a little bit of random to that, say 0.5. And now you'll notice that we're starting to get a little bit of vertical spread. Let's say if we set it up to 1, we should get even more. And then if we add the same amount in z, now we're actually emitting outwards in a cone-like shape. Because we're getting a little bit of random velocity in z, a little bit in y, and then a primary velocity down the x-axis. Cool. Now the last thing I want to talk about is emitter velocity scale. Now that's if you've never been exposed to particles before, that name could be a little bit confusing, but what this is how much of the velocity of the actual emitter is imparted to the particles. It's really only useful if the emitter itself was moving, and unfortunately, you can't test it by grabbing the emitter and throwing it around in the view.
Right. If you remember, the emitter that you see inside the scene view is a simulation that's there just for you to get an idea of what your particle system is going to look like in the game.
Right. It's just a preview.
Right.
So what I'm going to do is take all of my velocities, and we'll pull them all down to 0, 0, 0, 0. Now, our velocity scale by default is set to 0.5. That will work, but I want something a little more dramatic. What this is a percentage of the overall velocity that the emitter already has, which is being sent down to the particles the moment they're born. So what I'm going to do is set this to something like 0.75. Again, it's not going to do anything that you're going to be able to see while you're playing with it. What you need to do is get this emitter moving. What I'm going to do is animate the thing. So with it selected, let's go under Window, jump down to Animation. And I know we just did something very similar in the last video, so this should go pretty quickly. Let's go ahead and just click Record. And we've already got an animation curve on it, which is pretty cool for us. As a matter of fact, let me make sure that I kill off those previous keyframes, because I now no longer want to take my emission rate that I animated in the last video. I don't want that to change anymore. So just make sure all of that goes away. And we'll make sure that our min-max emission is simply set to 100 the whole time. Okay. Now, back up here in our transform, I'm going to animate our particle system just wavering back and forth in X. So let's just take position X, and we'll keyframe it right here where it is. And let's not use just 2 seconds here. Let's go up to around 5 seconds. And we'll move it way over here. Now, all I'm going to do is come down underneath my animation type, and let's just set this to ping pong. So that's just going to cause the the particle emitter to just go back and forth over and over and over. If we want to be really fancy, we can right-click on both of our keys and then come down and set these to flat, and that'll give us a nice ease in and ease out transition while we move. As a matter of fact, if I hit F, you can now see that. We get a nice S-curve. Okay, so with that, let's stop recording. Let's close out our animation window. And if I hit play, if we come over and take a look at our particles, you can kind of see the emitter moving back and forth. But notice that it's kind of slinging particles. As it turns around, some particles still continue moving. Now, I don't have any motion. Take a look over here inside my inspector while this is playing. Local velocity, random velocity, and world velocity are currently all set to zeros down the board. Yet our particles are still moving. That's because currently 75% of our total velocity on our emitter is being imparted to those particles, which is why they continue to slide along. If I was to set this all the way up to 1, now it's 100%. So now it's actually going to look like a glob of particles that moves along with the emitter while it moves back and forth. And then when the emitter turns around, they just keep right on going. They don't slow down at all. Or we could set it down to something really low, like 0.2, and they're going to be kind of lagging behind while they're born, but still moving in the same direction that the emitter was. So it's just a neat way to steal some of that velocity that your emitter may have and impart it to your particles if you need that. And there's all kinds of reasons. Like, let's say you've got some pieces of debris that are falling off of a train while it's chugging along. You know, something that actually has some mass, as opposed to, you know, magic sparkles or smoke or fire, that sort of thing. If you've got those pieces of debris falling off the train, they've already got some velocity when they come off the train in the first place. And this is how you could impart that. Maybe grab, you know, anywhere from 75 to maybe all the way up to 100% of that total motion, so that as they're rolling off, they're moving along with the train, maybe just a little more slowly, so they start to trail out behind. But that's how you could get that effect. So that covers all of our linear velocity properties, and that will wrap things up for this video. Thanks a lot.